This is part 1 of the week 2 lecture for Mth090. We'll start with section 1.1 of your book on fractions. So, we know a fraction has a numerator and a denominator. An improper fraction has a larger numerator than the denominator. So the top number is going to be larger than the bottom number. And this improper fraction we can turn into what we call a mixed number. A mixed number is a whole part, a whole number, plus a fraction. So with an improper fraction, your fraction is worth, or the value of the fraction is bigger than one whole. Thus, we can write it as a mixed number. In order to turn a mixed number into an improper fraction, you take your denominator, multiply by the numerator, your denominator multiplied by the whole number, then add the numerator, and that would be the top of your fraction or your new numerator, and you would keep the denominator. So for an example, 4 3/8, if we have 4 3/8, kind of call this a backward C. You start with the 8, multiply by the 4, add the 3. That becomes your numerator once you figure that out, and you keep the 8 as your denominator. 8 times 4 is 32, plus 3 is 35. So the numerator is 35, the denominator is then 8. So the mixed number 4 3/8 converts to the improper fraction 35 over 8. And one key point, or one thing you have to remember, if you are able to reduce your fraction, you must. All fractions must be written in lowest terms. So if we look at 35 and 8, they don't have any factors in common. So that would be the final improper fraction. Now to turn an improper fraction, to a mixed number, you have to use your skills of division. You take the numerator and divide it by the denominator. So let's look at 23 over 9. You have to think to yourself, 9 goes into 23. How many times evenly? So this fraction is 23 divided by 9, or if you think of it backwards, it's 9 goes into 23. Well, I know 9 times 3 is 27, so that's too much. But 9 times 2 is 18, right? If we take 23 and divide by 9, I know it goes into there twice. 2 times 9 is 18, and when I do my subtraction, I have a remainder of 5. That remainder is your numerator of the fractional portion. So the whole number is 2. The remainder becomes your numerator, and the denominator is the same as the denominator you started with, 9. So 23/9 is the same as 2 5/9. Okay, so when we multiply fractions, if they are if they are improper or proper fractions, a proper fraction is when the numerator is smaller than the denominator. All we have to do is multiply our numerators and then multiply our denominators. And remember to always, on the outcome, your final fraction, make sure it's in lowest terms. So if you look at the 2/9 times the 5/7, we just multiply 2 times 5 to give us 10. We multiply 9 times 7 to give us 63. Then we look at 10 over 63. to decide if it can be reduced. Here it cannot, so it's already in lowest terms. If we multiply a fraction times a whole number, remember a whole number is a fraction with the denominator of 1. So if you rewrite it with the denominator of 1, then you're following your same rules. Multiply the numerators, multiply the denominators. So you can multiply them and then reduce, but sometimes the reducing comes easier if you do it beforehand. So let's look at 2/9 times 5/7. So if we multiply 2 times 5, we get 10. If we I'm sorry, that's not the one I wanted to do. 2/7 times 42. So we rewrite 42 as the fraction 42 over 1. So if we just keep multiplying, we get 84 over 7. And then you have to decide if you can reduce that. Well, if we look at 84 over 7, you don't readily see how to reduce, but you can divide 7 out of both top and bottom here. So if we divide out the 7, we get 12 over 1, right? 84 divided by 7 would be 12. 7 divided by 7 would be 1. And our result is 12. Now if you reduced in this step, I know 7 times 6 is 42. So I can reduce that by 7 to get 1, that by 7 to get 6. Then I have 2 over 1 times 6 over 1, which gives me 12 over 1, which is just 12. So it's up to you when you want to reduce, but sometimes it's easier to see before you actually multiply out the numbers. Okay, so if we look at 3 over 20 times 6, again, 6 over 1, and I know that 6 and 20 have a common factor of 2. So if I reduce those before I even multiply, then I have 3 over 10 times 3 over 1, which gives me 9 over 10. Now if I hadn't reduced it, I'd have 3 over 20 times 6 over 1, which gives me 18 over 20. And from here, I know I have a 2. Both numbers are even. So 2 goes into this 9, 2 goes into that 10. So 9/10. So that one was pretty easy either way. Now, when you're taking a fractional amount of something, you're actually multiplying. If I want to know what 1/8 of 32 is, I'm going to take 1/8 and multiply by 32. And again, 32 over 1. If I reduce before I multiply, 8 goes into 8 once, 8 goes into 32 4 times, so I have 4 over 1, which is just 1. So 1/8 of 32 is 4. Think of it, if you're taking half of something, half of 10, you're actually multiplying 1/2 times 10 over 1, which gives us 5. Half of 10 is 5. So anytime you're taking a fractional amount of something, you're multiplying. Now, one other thing I wanted to mention, the reason we change the mixed number to an improper fraction, say I have 2.5 and I want to multiply by 6. Well, if I change the mixed number to an improper fraction, I get 5/2, right? 2 times 2 is 4, plus 1 is 5. That's my numerator, and I keep the denominator. Now I can multiply 5 halves times 6 over 1. 2 goes into there once, 2 goes in there 3, so I get 15 over 1, which is just 15. So when you're multiplying a mixed number times anything, turn it into an improper fraction. Okay, so let's switch gears a little bit and talk about dividing fractions. Dividing a fraction is very similar to multiplying a fraction. You're actually going to take your division problem and turn it into a multiplication problem. Now, in order to do that, you have to take the fraction that is doing the dividing and flip it upside down. We call that the reciprocal. So remember, a whole number is a fraction over 1. So 15 is the fraction 15 over 1. Its reciprocal would be 1 over 15. 7/10, the reciprocal would be 10 over 7. So when you're dividing, 7/9 divided by 8/15, this will be turned into a multiplication problem. The 7/9 is a fraction that's being divided. 8/15 is the fraction that's doing the dividing. So we multiply by 15 over 8. Now we've changed our division problem into a multiplication problem, and we know how to multiply. Multiply across the top, multiply across the bottom. Now I see I have a 9 and a 15 that can be reduced. 3 goes into there 3 times, 3 goes into there 5 times. So I actually have 7/3 times 5/8. 7 times 5 is 35. 3 times 8 is 24. And again, make sure it's reduced, which 35 and 24 have no common factor, so it is reduced. 5/6 divided by 8 is the same as 5/6 times 1 over 8. Multiply across the top, 5 times 1 is 5. Across the bottom, 6 times 8 is 48. And 5 over 48 cannot be reduced. Therefore, that would be your final answer. And that is the end of Part 1 lecture.